Welcome to this video. We are going to calculate your acceleration due to gravity using the data you collected in class. We had the object falling. We recorded the time at which it had various positions as measured on a meter stick. So here's my object. I didn't actually drop it till 1.2 seconds into the video. So that's when I first dropped it, and it was at the top of the meter stick. And then as time passed, here were the values I recorded from the video. The first thing is to find the displacement. The displacement initially is just 0 in my case. Now, we're not actually going to fill in that first blank because for displacement, you need two data points. You need a final and initial. So we're going to take this as our final position, and that is our initial. And then to get the displacement, right, you do y final minus y initial. Your final is 0.9, your initial is 1 meter. So you subtract 0.9 minus 1, and the displacement comes to negative 0.1. Then we continue. And the way I'm going to do it is I'm going to continue and consider successive intervals or successive displacements. So between these two moments, what is the displacement? From here to here, we go from a final of 0.6, right? Y final is 0.6, and the initial was 0.9. So you do 0.6 minus 0.9, and you get negative 0.3 meters. And then we, again, find the displacement between these two. So 0.1 minus 0.6 is negative 0.5. Good. Okay. Now we need to find the velocity. We are going to make an assumption that's not totally valid, but it'll be good enough for us for these purposes. Let's assume during this interval, let's assume that the velocity is constant. Okay? The value of velocity that we get, the average and the constant value, is simply given by the displacement over how long it took for the displacement to occur. Now, the displacement is this. You just found it. The time it took for that displacement to occur, well, we found this displacement by taking 0.9 minus 1. So 0.9 and 1, those were separated, those two positions were separated by, look at this, 0.15 seconds. Okay? So here's what you're doing. You're taking, the velocity is the displacement, which we know, and you're taking final time, which was 1.35 seconds, and subtracting the initial time, when you had the initial position, which is 1.20 seconds. So that's 0.15 in the denominator, and we do negative 0.1 over 0.15, and you get negative 0.6 repeating. So I'm going to take this work away because I don't have enough room, but you can show the work in your notes. Negative 0.6 repeating. So I'll just show a couple of sixes and then do that. Meters per second. Right? Okay then, let me get rid of this and this. Now we're going to move, Now we're going to move to the next interval. Okay? This interval had a displacement of negative 0.30, right? Because if you look over here, that's a difference of 0.30. And the object goes down, so negative. All right, then, what do we want to do? We want to say, find the velocity. Velocity is displacement, which is negative 0.30, divided by the interval of time you considered. To go down 0.30 seconds, it took 0.15 seconds. Right, final time minus initial time is 0.15. So that's really easy. That's -2, right? 30 over 15. Next one is this, the final, the last of our intervals. So the displacement during that interval was -0.50. How long did that interval last? Again, it was 0.15. And this comes to -3.33. 3.33 is what I got. The last thing we'll do is find the acceleration from this velocity data. So we're going to now, let's use green for that. Acceleration is equal to the change in velocity over the change in time. The change in velocity is just final velocity minus initial. And the delta t is the same thing we've been looking at all along. So from this moment, let's consider this interval of time. The velocity changes from an initial value is this. That's the initial value. And we have to subtract that value away from the final value. And this was our, This is our final value, -2. So you do final minus initial, that's the numerator. The delta t is just how long it took to change your velocity by this amount. So what's our interval? Again, 0.15 seconds. We're saying that this is the velocity we had at a time of 1.35. -2 is the velocity we had at a time of 1.5. So you do final velocity minus initial velocity over final time minus initial time. Right? And let's see what we get. -2 minus a negative, so that becomes plus 0.666667. Enter, and then divide by 0.15, the time. And it's -8.9. You want to show this work, right? Show this work. I'm not going to show it because there's not much room here. So let me get rid of all those circles. Get those gone. Okay, so I do all this work, and it's -8.9 meters per second squared, which is not too far off from -9.8. That's 9.81 is the true value. And look, I'm pretty close. I'm like -9. That's pretty close. And then I do it again. The acceleration is the change in velocity. So our velocity changes from that to that. And as it undergoes that change, the time goes from 1.5 to 1.65. So our acceleration is final velocity, 3.33333, minus the initial velocity, which was -2 in this case. And you divide by how long it took to make that change, which was, the final time was 1.65 seconds, minus the initial time, which was 1.50. So again, it's 0.15 in the denominator. And what do we get? Negative minus a -2, which is plus, and then you divide by 0.15. It's the same thing. Wow, that's pretty cool. I had a constant acceleration of -8.9. I got the same value both times, which is good because when something falls down, the acceleration should be constant, and mine was. But the acceleration should be a constant -9.8. And I was pretty close. -8.9, that's not too bad.